Hello class, welcome to the next segment in the week 4 material, and in this segment we're going to take a look at sort of the same thing that we had in the previous segment, but we're going to take a look at a different Boolean operator. So in the previous segment we took a look at the OR Boolean operator, OR, and in this segment we're going to take a look at the AND Boolean operator and see how that changes things. So same exact program that we had previously, except here we're replacing OR with and in this case, in the case of the OR operator, we were requiring just one condition out of all of the conditions. We were requiring just one condition to be true in order for the answer to the entire question to be true. In the case of the AND operator, we require every single condition to be true in order for the entire thing to be true. Or we require the answer to, in the case of spelling out each individual condition, we require each and every condition to be satisfied in order for the entire condition, the entire thing in the if statement to actually be satisfied. So if we take a look at the sort of the same thing that we had previously, again, it's the same idea, except here we have and instead of or. And the setup is very much the same, just like the or operator. Each condition has to be explicitly spelled out on either side of the and operator, just like with the or operator. But if we take a look at what actually happens when we go through this program, so again, x is still 10, y is still 10, and we go down here on line 6 and get the computer to ask this question. And from a visual inspection, we can see that x is in fact equal to 10, and we can see that y is in fact equal to 10. And since both those conditions are met, and the AND requires both conditions to be met, so since AND has that requirement, and we do in fact have both conditions being met, those are both true, then the answer to the entire question in this if statement is true. And just like any other if statement, if the answer to this entire thing is true, then whatever's indented below that is something that the computer will act on. So in this case, printing out that's 1. Again, the same exact program that we had previously, except here we're using and instead of or in our conditions here. And in the case of line 9, again, we are requiring that both of these conditions on either side of the and are true in order for the computer to actually act on anything. So here we have a condition that is true. X is in fact equal to 10. We can see that from a visual inspection. And here we're asking if y is equal to 15, which we can see that is not the case. So we have a true condition or a true statement on the left-hand side of the and, but this condition on the right-hand side, that's not met. So since and requires both of those conditions to be met in order for the entire thing to be satisfied, then this if statement is going to fail. This condition in the if statement on line 9 is going to fail, meaning the computer is not going to run this indentation that appears on line 10. And if we go down to what's on line 12, asking if x is equal to 15 and y is equal to 15, well, this condition fails because x, we can see, is not equal to 15. X is in fact 10. And just like on line 9, y is also not equal to 15. And requires both conditions to be true in order for the entire thing to be true, but since neither of these things are true, then this condition fails even more than before, because since we require each and every condition to be true if we're using the AND operator, and since none of these conditions are true, x is not 15, y is not 15, so this if statement especially fails. It is especially unsatisfied, but it's still run pretty much the same way. This indentation in line 13 is not going to be something the computer acts on because the condition up here failed. And unlike the OR operator, the Boolean AND operator, which is given by the word AND, this is a bit more intuitive than what we had in the previous segment, where the OR operator was a little bit unintuitive. You might be tempted to spell things out in plain English, which can lead to some confusion. But the AND operator, on the other hand, is a little bit more intuitive, but also a little bit more restrictive. But if we want to verify that this is in fact what's going on, so we expect this condition to be met. So since we require both of these things to be true, and both these conditions to be true, and we can see x is equal to 10 and y is equal to 10, so this entire thing should be true, so it should print out that's 1. We establish that this is something that will fail, and this is something that will especially fail. So that means this print statement that's indented on line 10 will be something the computer ignores, again, just like any other if statement. And this statement on line 13, which is indented, again, just like any other if statement, is going to be ignored because this condition fails. So the only thing that we expect the computer to act on will be this print statement on line 7. So therefore, the computer should just print out that's 1 if our logic here holds. So let's see if we actually get the result that we expect. So I'll go ahead and run this, and you can see we do in fact get only one result appearing in the console, and that one result does in fact correspond with what we deduced up here on line 6 and 7. So that's going to do it for this segment on the AND operator. And there's one more operator that we're going to look at, and that is the NOT operator, which we'll cover in the next segment. There is another one that I'll sort of talk about, but for a very good reason, it's actually not even part of Python to begin with. But I will briefly talk about that operator in the next segment, just to sort of summarize what we've talked about so far. In the case of the OR operator, again, we can take a look at that again. We require just one. It takes two conditions and it requires just one to be true. The AND takes two conditions and requires everything to be true. So OR requires just one thing and requires both conditions to be true in order for the entire thing to be true. But since we're done with that summary, we'll go ahead and conclude the segment, and we will proceed to the next segment where we talk about the XOR operator briefly and the NOT operator. So with that, I will see you all there.